Hi, I'm going to do an unboxing video of the Maxitronics 501 electronics kit that I've recently picked up from eBay. I've got quite a thing for these kits. I had one as a boy, probably age 10 or 11, and it wasn't the same one, but it was this kit here. As you see, as an original 151 kit. Morse key. I've had some circuit on here, I can't remember what it does. It's been great fun, and I've always enjoyed these things ever since a little lad, and I'm so pleased that you could still get hold of them on eBay to this day. So not content with that one. The next one up from that is the 300 in 1. The difference, you can see clearly that they give you a breadboard to put components on. There's all my stuff everywhere, and a different layout. Essentially, this kit does everything that does, plus 150 more projects. And then at the top of the range model is right here, the 501. This model boasts everything that all the other kits can do, plus the extra 200 projects, whereby you'll be using a keypad to program this little microprocessor controller here. 4-bit input, 8-bit output, connections here so you can access the clubs, spades, diamonds and hearts icons in black. And this screen lights up for programming. There is a game built into this apparently, some kind of number invader. Numbers scroll across the screen, you've got to match your number here to get rid of them. I feel it's a complete waste of computer space, because I don't think the manuals actually show you how they did that and how you could program a little game onto it. All the projects in here are strictly for running logic sequences on things you've built on your test board. The display and LEDs giving outputs. Yeah, so it was a bit of a shame that they wasted valuable, precious memory on a useless inbuilt game, and they don't even tell you how it was programmed or give you the programming skills with the kit to make your own games. It was a bit of a shot in the foot for them, I think. But anyway, let's get on with the unboxing. Now, I've been looking at these on eBay, and the only ones I could see were from America, coming in at about 130, 150 pounds UK, but with the import taxes and postage you'll be looking at more like 230, 250. This one came up in the UK and I got it for a good price, pretty well on par with what the Americans were costing. This one is brand new, in mint condition. A couple of little scuffs on the box, but inside, here we go, everything is still in its wrapper. There's the unit itself. Oh. Carry case. Lid pops up, we'll just take it out in a second. All the original packing, as you're seeing, is still here. Components still in their bags, sealed. Wires still wrapped up and straight. Never been used. Brand new. 3 manuals, which are all still in their wrappers and still sealed. So you've got your hardware entry. These will cover the same kind of projects as you do on a 300 kit, and something a bit more advanced where you'll start using the LCD display and more logic projects. And finally the software programming course, which will go into detail on how to operate that keypad and program the microcontroller. And yeah, finally, batteries and what condition they are in. Yeah. So let's take a look. Maxitronics 501 serial number. What's that say? The ages 10 years and upwards, made in China. So for a 10-year-old upwards, I'm not sure, I haven't properly dated this. Is this late 1980s or 1990s, I think? So it opens up like that. And provided some little hooks there. This sounds reasonably well. You've got to take care of this data cable. So I was like looking for you there on the screen, and I've got a bit of. If I close my curtains and see it better. That's better. There's less glare there. So let's just take you through this. What we've got, we'll go from top down. So we've got LEDs, 8 of them, in 8-segment LED display, phototransistor, cadmium sulfide cell, another light dependent device, some terminals for connecting wires, a speaker, and we've got the computer power switch, the inputs, LCD access, and the chip outputs. That's just a picture. The LCD screen, standard tuning coil for radio projects, tuning capacitor, stiff movement there, and half turn. You get nice small movements. We've got a 500 kilo ohm pot and a 100k pot, output transformer battery box, double pole switch, single throw, and 8 odd push and slide switches. So you can push them, slide them. I'm pretty sure there's it's pressing down, so you can use it like a tap key, press button in both positions. And then we have the programming keyboard, the multifunction keys, and it explains later on in the manuals how you can switch between selecting numerals versus commands, etc., and how to enter and run your programs. These sections here, they unclip off and give you a kind of compartment there to put components in, but I dare say it'd be messy. The 300 kit, they give you like little trays with ducats you can put your bits into, and there's the compartments here by the looks of it. I don't know if this pings out. More than likely. There we go. You've got a tray for things, so you could put your bits and bobs in there. Not the bestest of shapes, but just utilising the space they've got in the casing, I guess. Have we got any batteries? Let's have a look. Just 2 seconds. So that off-camera clatter tells you I found some batteries. And so both sides to open. Come on. So the screen's lit up, and it's now flashing game mode. You got program, a debugging mode, and running the program. I think maybe you press run. Enter, is it? It'd be one of these. There. So we've now got a underscore and a 1 here. There's the 1's appeared over here now. Oh, and I can scroll there. Press enter. Is that it? You just got to get under the number, or do you press the corresponding number? Right, learn the keypad. Oh my gosh. Oh, there's a 2. There's 2. Bang. There's 3. And that's how it works. 4. Oh my god, there's 5 on here. My glass is terrible. I think I've missed that one, guys. Bang. Let's go along with 2. So here we are. There's this game, the novelty game that they've put into the computer, and I don't know if you can actually access any of the internal workings. It's given me a score of 14 by the looks of it. So how do you get back to escape, is it? Yeah, so we're back there. And you can cycle along with the arrow keys, go into program mode, debugging and running. So have a quick look at program. So there, now at this point we've started it, the first line of the program, it's automatic numbering in hex. And here it'll be asking for a command to put in. So if we'll try and pick one, which is the move command. Okay, and then press enter, maybe. Yes, and then it's asking the next entry. So we'll say we're moving a value into accumulator A, and we'll make that value 10 in hex. Press enter. It advances automatically to the next line. So we've added a value of 10 into accumulator A, and so for output, double press there, you see to change it's in or out on that button, so you can just cycle through. So we'll output button A for that line, and for the final line we'll stop the program, and that's it. So how do we now get back to, so if we escape back, cycle along, and theoretically if I press enter, then we should get the value of 10 on the screen. Run, enter, go, run button. Is that an illegal error at line 2? I don't know. It's just a basic run through. We'll have to look in the manual properly, but at least it's part demonstrated that this thing is actually functional. I wrote a crap program and there's the answer. So all good, so far so good. So just to close up on this video, we'll have a quick look at these manuals. Quick run through what kind of projects you can do. Have the date 2001 on the back of the manual. It was only 20 years ago. So these will be your standard set of your parts lists. This will be exact copy of the 300 manual. All the regular stuff, like control boards, transistor radios, you know, the funny transistor crystal sets, and so on. Operational amps, decision making, fun projects. Depends how deep you want to get into it. So it's taking us up to 254 projects here. So that's half of them in that book alone. Manual 2 is a lot thinner. It's just advanced course. So we'll take a look now. Teaching about volume control, memory backup circuits, made comparators, more sound projects, more radio, including an FM transmitter, but unfortunately I've looked through this manual on a PDF from online and there's no FM radio, unfortunately, which is a shame. I wish they would have put that in. It's very possible. So yeah, there's timers and the likes here, some logic stuff, more testing circuits, pulse width modulation, oscillators, it's all there. How many projects was that? Numbering up to 400. Now the last 100 projects are in this book, and this is the book that takes you through how to use the computer and how to program it properly, and combine it with circuits that you're building on your breadboard to give you more of a fun experience, I guess. So we'll start with all the run through of how this system works, along with explaining the instructions, the carry flags, in and out instructions, everything you need to know to run it. And then finally it'll start giving you projects to using programming. We have such things as do, re, mi, fa, sol, la, playing the musical scale, logical operations, switching entries, using the LCD, there's playing card symbols, how to light them up, digital dice, digital roulette, digital volume changing, which is handy to know, illumination control, which is good for LED lighting projects. So we'll take a quick look in, and it gives you a basic rundown of the internal structure, which some of you will be very familiar with a diagram like that. 4 input ports and a arithmetic logic unit, 8-bit output. We have 6 accumulators, A through to F, and a 64 entry memory, and the keyboard interface, and finally outputting to the LCD display. It gives you a full rundown of what happens on the screen, what you're looking at, the hex numbers, the program, the instructions you're giving, what register you're operating on, and the data you're inputting or processing, and so on. And then we will go step by step, introduction into flowcharts, an algorithm structure, and step by step you get to grips with just how to enter the code and what will happen when you do. So there's a lot of reading here, there's a lot to take in if you're not familiar with this kind of stuff. So we've even got a little beeper on board, I found, and depending on the frequency you get the 12 notes chromatically scale. There's a thing I've noticed when I've looked through the manual about the way that the computer reads the program, and apparently, I don't know if you can see on here some of these commands, how well you can see that. Just focus there for you. There's 3 BON commands, and there's different values, do, re, mi. Okay, but apparently when the CPU reads, it reads the first one. If it sees the second one, it ignores it. It's something like that. It does some kind of ignoring feature where if you have 3 commands, no matter what they are, it'll pass on them and only operate on one of them. I'll have to look into this more because I need to read this manual further. But in other words, if you wanted to give, like, say 3 or 5 beep commands in a program, and you would expect as you run through the program lines, beep, 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 it seems to imply that it will just ignore the one because they're all in a chain and similar. I'll set up an experiment from out of the book later on in another video, and we'll see what how this thing functions in more detail. So I'm just going to randomly open up the page now and grab just one project. This one's number 404, a binary counter. Woo! With a sub instruction. So here you're only going to put a few kind of resistors onto the breadboard, and the rest of the wires are going to go up to the little microcontroller to operate 4 LEDs. And according to this sequence here, the LEDs are going to light in the same way, 0 being on. Yeah, 0 is on, X is off. So there's 4 lights on, then 3, then the last 2, and the first one. It's making a sequence of lights. So if you ever wondered, like in modern times we have these fancy LED strips, and at the press of a button it changes pattern. That's exactly what's going on there. There's a little program that operates the LEDs by microcontroller, and this is the very basics of it. And so, as you can imagine, as the book goes on, it becomes even more involved. The programs will be becoming longer, and to be taught more and more arithmetic functions to get the desired output. So, like here we see a project where we're now using a logic chip on the breadboard with supporting components. This one happens to be a leading edge detector for an input pulse, whatever that does. I do know, but we're not going to go into any heavy details. And then the opposite circuit to find the trailing edge of an input pulse. This will be to determine the pulse width, and so on and so on. Let's go for, see if I can find a even longer one. Audio level meter. How loud is something? So basically we've got what's this here? We've got an audio amp or a comparator set up. Amplify what's coming in from the earphone, and then the output will be shown on 4 LEDs just how strong that signal is. And they've included a program to go alongside that. It says here, when you talk into your earphone, the sound signal from it is amplified by a 546 chip, rectified by a diode and capacitor, sent through the IC2D comparator, and the amplified sound signal is also supplied to the speaker, and there it is, and also on LEDs. While the program is running, turn on the power switch and speak into the microphone or earphone. The comparator IC2D gives out an input voltage to the comparator IC2A, and you can adjust the volume of the audio signal by using your control. Yeah, so there's going to be a lot of things you can do in one of these kits, and of course once you get used to how to use it, I'm sure you can make your own projects outside of what they've taught you here. So there we go, that's the Maxitronics 501 electronics kit.